Angle bisectors. The angle bisector theorem says if a point is on a bisector of an angle, then the point is equal distance from the sides of the angle. All right. So let's look at what this means. Given line AD bisects angle BAC. So that's going to mean this angle, BAD, is congruent to angle DAC. Given AB is perpendicular to BD, so we have a right angle. Given line AC is perpendicular to CD, so we have another right angle. So then we can say that line segment BD is congruent to line segment DC. Because we have congruent angles here, we have a bisector, and we have our perpendicular lines. So our angle bisector bisected that angle. And it's also equal distance from the side. So D is equal distance from C, AC, and D is equal distance from AB. Converse. If a point is on the interior of an angle and it's equal distance from the sides of the angle, then the point is on the angle bisector. Again, let's look at our angle. Given line segment BD is congruent to line segment DC. Given line AB is perpendicular to line segment BD. Given line AC is perpendicular to CD, then we can say that line AD bisects angle BAC. So that means that the measure of angle BAD will equal the measure of angle DAC. So let's see how this works. Let's take a look at our first triangle. We're trying to find x. We notice that we have an angle bisector because these two angles are congruent, and we have two right angles, which means that this point lies on the angle bisector, and this point is equal distance from both sides. So we can take 9x minus 5 and set it equal to 4x plus 30. We're going to solve for x by 0 pairing out the 4. We're going to have 5x minus 5 is equal to 30. 0 pair out the 5. 5x is equal to 35. Divide by 5, divide by 5. X is equal to 7. So we can say that 4x, I'll go ahead and put in the 7 there, okay, plus 30, 28 plus 30, 58 is the length of that first line segment. And now we're going to check that 9x minus 5, 9 times 7, minus 5, 63, minus 5 is going to give us 58, which means our second line segment is 58. Both are congruent. All right, here we have our next triangle, and we can tell that this point is equal distance from the two sides. We have perpendicular angles, perpendicular lines causing right angles, so this must be an angle bisector. If it's an angle bisector, then these two angles are congruent. So we can say 8x minus 441 is equal to 5x minus 11. 0 pair out the 5x. 3x minus 41 is equal to 11. 0 pair out the 41. 3x is equal to 52. Sorry, this is negative 11, which is going to change this to positive 30. Divide by 3, divide by 3, x is equal to 10. So now we're going to find the measure of the two angles. We're going to do 5x minus 11, 5 times 10, minus 11, 50 minus 11, 39 is our first angle. 8x minus 41, 8 times 10, minus 41, 80 minus 41 is 39. And that's how you use the angle bisector theorem and converse to find missing parts of a triangle.